Have you ever stopped to think about how an entire factory, I mean everything from the very first design sketch to the final robot tightening the last bolt, could actually work together as one single thinking entity? How do you get every machine, every department, every single piece of data to speak the same language? Well, let's dive into that. Today, we're exploring the concept that tried to solve that exact problem: computer integrated manufacturing.
At its heart, computer integrated manufacturing, or CIM for short, is this huge, ambitious idea. What if we could create a factory that thinks? The goal is to connect all the separate little islands of a manufacturing operation, design, engineering, the assembly line, even the business office, and turn them into one cohesive, intelligent continent where information just flows freely. This isn't just about sticking a few robots on a line, it's about fundamentally rethinking how a factory operates from the ground up. So take a look at this. In a typical factory, these might just be separate stations, each doing its own thing, totally isolated. But in a CIM system, this is a single organism. The welding robot knows exactly what the painting station is doing, the inventory system knows precisely when to send more parts, and management? They can see the status of absolutely everything, all in real time. That's the key. So what is it, really? The official definition says CIM is all about using computers to control the entire production process. And that word, entire, that's everything. We are not just talking about automating one little task. We're talking about a top-to-bottom integration where computers are overseeing the whole shebang. And the payoff? Well, imagine being able to switch a production line from making one car model to a totally different one in a fraction of the time, just because the whole system can adapt together. That's the power CIM is aiming for. What's really interesting about this quote is how it frames the idea. Notice it says the technology has to be coupled with new managerial philosophies. That tells you right there that CIM is just as much about people and process as it is about machines. You can't just go out and buy the software. You have to fundamentally change how the organization itself thinks and makes decisions to really unlock that power. Okay, so if a CIM factory is one big cohesive body, then where's its brain? Well, that's the digital layer. All the software and data that act as the central nervous system for the whole operation, making the decisions and sending out all the commands. And this slide perfectly illustrates the journey of an idea right through that digital brain. So let's walk through it. It all starts in CAD, computer-aided design, where an engineer creates a 3D model. That model then gets passed to CAE, computer-aided engineering, for all kinds of virtual stress tests to make sure it won't break. Next up, CAPP, or computer-aided process planning, figures out the most efficient step-by-step recipe to actually build it. And those instructions? They go to CAM, computer-aided manufacturing, which tells the real machines on the factory floor what to do. And watching over all of it is the ERP system, managing all the resources and making sure everything lines up with the bigger business plan.
So, how do all these different pieces of software, from design to management, actually talk to each other? Well, here's the secret sauce: a common database. Think of it as a single source of truth that every single system can read from and write to. Without this, the design team's data might not match the manufacturing team's instructions, and that's where you get errors and delays. This shared data pool is what transforms a bunch of separate tools into a truly intelligent integrated system. It's the absolute heart of CIM.
All right, so let's move from the brain down to the body. We've seen the digital plan, now let's look at the physical hardware that actually brings that blueprint to life. How do all those digital commands get translated into physical action and, finished products? This is where the digital plan smacks right into the physical world. The CAM software sends its instructions to CNC machines, which then execute these perfectly precise cuts. PLCs act like these little mini brains for specific processes, making sure they run just right. Robots, like you see here, handle assembly with tireless precision. AGVs, or automated guided vehicles, they're like the factory's circulatory system, moving parts exactly where they need to be, when they need to be there. And all the while, automated storage systems are managing the inventory. It's a symphony of hardware, and it's all being conducted by that central digital brain. But here's the really clever part. This isn't just a one-way street of the brain telling the body what to do. Nope, it's a closed-loop system. You've got sensors all over the factory floor constantly feeding data back. Think of it like a nervous system. If a drill bit starts to wear down or a motor is getting a little too hot, the system gets that real-time feedback and can adjust on the fly, or maybe flag a human for help, preventing errors before they can even happen. Now, it's all this talk about automation and intelligent systems. It's pretty easy to imagine a factory with no people at all. So what's the real role for humans in a CIM system? Well, the answer is maybe more important than it's ever been.
There's this persistent myth of the lights out factory, right? A plant that just runs itself in the dark. But the reality of CIM is that it actually elevates the role of people. See, the system can handle all the repetitive, predictable tasks, but it's the skilled engineers and technicians who manage the unexpected, who troubleshoot the really complex problems, and who make strategic decisions the system just can't. CIM doesn't replace human expertise, it supercharges it.
And let's be real, building a true CIM system is incredibly difficult. One of the biggest hurdles is just getting equipment from all these different vendors to speak the same digital language. It's a massive integration puzzle. Then there's the huge challenge of keeping all that shared data accurate and, of course, secure from cyber threats. And like we just talked about, you always need highly skilled people on hand because no system can predict every possible failure or every new opportunity. So with all these challenges, you might be thinking CIM is just some old concept. But that's not it at all. In fact, its core ideas are more relevant today than they have ever been. They form the absolute bedrock of what we now call Industry 4.0. Yeah, this dream of a totally integrated factory started way back in the 70s. It was formalized in the 80s, and people built frameworks for it in the 90s. And today, well, those fundamental principles, total integration, a common data source, and closed-loop control are precisely what power the smart factories and the whole Industry 4.0 revolution that you hear so much about. The name might have evolved, but the core vision is exactly the same. Which brings us to a final thought, and it's a bit of a provocative one. The vision of CIM promises this hyper-efficient, incredibly responsive, intelligent factory. But it also introduces just immense complexity. So the question we're left with is this. As we keep going down this path of total integration, are we really building better products for people, or are we just creating a more complex machine for its own sake? It's the central tension that we're all going to have to manage as we design the future of manufacturing.